Why do we always let artificial intelligence just guess the answer?
Right. We expect this instant gratification from our digital tools.
Yeah, but a human expert never starts without a solid plan. Human experts naturally build a mental scaffolding before they even touch their tools,
Exactly. They define the boundaries of the problem first.
which is exactly what we need to teach our AI. Welcome to the deep dive for today. We are exploring a fascinating structural shift with you.
It's a huge shift, honestly.
Our mission today is unpacking a highly specific blueprint to transform your AI usage. We are going to recreate the coveted Fable 5 workflow inside Claude.
And we want to specifically focus on the Opus model for this framework. It is really important to implement this before usage windows potentially change.
Right, because we aren't just looking for one good AI output to solve a single problem.
Yeah, a good answer only helps you one single time. We want to capture a repeatable working style that you can actually scale.
That style spans across 5 distinct structural steps we will explore. Those steps are scope, evidence, attack, verify, and finally, report.
It sounds like a lot, but it flows incredibly well once you set it up.
We are also looking at 2 distinct tools today as we build this out. Claude Chat is generally designed for quick, browser-based tests, but Claude Code is built for deep, real-world project work.
It's amazing. It actually reads your local project files directly from your terminal.
That local integration changes everything about how the AI reasons, but whether you use the browser or the terminal, the framework remains identical.
Right, you have to force the model through these 5 specific cognitive checkpoints.
Okay, let's unpack this first crucial phase together. Step 1 is about scoping the task thoroughly before generating anything.
Because you really cannot execute a task you don't fully understand.
It's like hiring a contractor to remodel your house. You would never let them just start swinging a sledgehammer immediately.
No, I mean, that would be a disaster.
Right, they have to measure the entire kitchen before they even buy materials.
Yet that is the root of most AI failures today. Users just hand over a prompt and expect immediate execution.
They just hit enter and hope for the best.
Exactly. The AI starts writing long before it actually comprehends the deeper goal. Step 1 forces the Opus model to significantly slow down its processing.
We actually instruct it to write out a project scope first.
It must define what the real task actually entails. It needs to visualize what the final output should look like formatting-wise.
It also must map out all the constraints you provided in the prompt. I have to admit, I still wrestle with prompt drift myself.
Well, we all do. It's so easy to slip into.
I will ask for one small structural change to a draft, and I end up with a completely rewritten thematic mess.
Yeah, that happens because the model lacks a proper rigid scope. It just starts predicting the next logical token without a boundary.
Opus prevents that drift by explicitly defining those boundaries early on. When you use Claude Code, this scoping phase becomes even more powerful.
Opus actually checks your surrounding project files before scoping anything out.
It understands the entire neighborhood before it tries to build the house. 2-sec silence. That makes the first step incredibly grounded in reality.
It completely stops the model from guessing what good means for your project. If you want a publish-ready section, it knows that specific standard.
If you want a quick review, it consciously decides to stay brief.
That is the fundamental Fable 5 habit we want to copy here. You must force the AI to understand the job before doing the job.
You do this by asking it to generate a scope outline first. Before we move on, I have a practical question about this phase. What is the actual time cost of forcing Opus to do this deep scoping on simple everyday tasks?
Well, it might add 30 seconds of processing up front for the AI, but it genuinely saves you 3 hours of frustrating manual rewrites later on.
So use Sonnet for quick fixes, Opus for deep planning.
Exactly. It is the ultimate return on investment for your time.
But scoping is really only half the battle here. Just because Opus understands the blueprint doesn't mean it has the lumber to build it.
Right. You need the actual raw materials.
How do we prevent it from hallucinating the missing pieces? That brings us directly to the concept of checking evidence.
Step 2 is strictly about separating verified evidence from wild assumption. Before Opus explains, writes, edits, or makes any final decision,
It must carefully review the real inputs provided in your prompt.
we explicitly tell the AI to audit its available materials.
These inputs could be an article draft or your personal source notes. It could be screenshots or a detailed transcript from a meeting.
For software engineers, it might be a specific local file path. It could be a terminal error message or a broken function name.
Opus must declare what is clearly available to it right now. It looks directly at what we call the context window. Let me quickly define that technical term for clarity. Context window. The short-term memory the AI uses to read files.
That memory has a hard limit, which is why evidence checking matters. Opus scans that short-term memory to find the actual evidence.
We prompt it to explicitly state what crucial information is currently missing.
It has to highlight which claims require further human verification. Most importantly, it lists what absolutely cannot be assumed based on the text.
Right. And that changes the entire dynamic of the interaction. But I have to push back on this underlying premise slightly.
Sure, go for it.
Does the AI actually admit when it lacks sufficient evidence? Or does it just try to please the user by faking it?
Left entirely to its own devices, it will absolutely try to please you. The default behavior is to give you a complete, satisfying-sounding answer.
It wants to be helpful even if it's hallucinating.
Exactly. But the Fable 5 prompt structure fundamentally rewrites those rules of engagement. You are not asking it for an answer yet. You are only asking it for an inventory report.
How does the system prompt actually force that compliance?
We use strict structural tags in the initial instructions. It cannot move forward without that explicit declaration of missing files.
This keeps the final answer from sounding falsely confident later on.
It essentially prevents the model from standing on a shaky foundation.
It checks the input first, then it eventually builds the answer. It builds only from what is actually verified in the text. 2-sec silence. This brings up a technical distinction I want to explore. How does Claude Code handle this evidence check differently than Claude Chat?
Well, Claude Chat relies strictly on the text you manually paste into the conversation. Claude Code proactively inspects the actual files sitting in your local folder.
Chat relies on pasted text. Code reads your actual project files.
Yeah, it flags unsupported technical claims before it ever changes your code. Sponsor.
Welcome back to our deep dive into the Fable 5 workflow. We have a clear scope and we have verified our evidence.
But the initial plan the AI creates is usually still quite flawed.
We need to pressure test that blueprint before we start the actual build.
Step 3 is the absolutely necessary pressure test phase. Before Opus writes a paragraph or codes a function, it reviews its own plan.
We prompt Opus to act exactly like a critical senior reviewer. We are asking it to poke holes in its own logic.
It's forced to be its own toughest critic.
Whoa. Imagine an AI actively trying to break its own logic before typing a word. Beat. That is a massive cognitive shift from how we normally use tools.
It completely flips the traditional prompt and response dynamic on its head. It actively attacks the plan to catch weak assumptions early in the process.
It explicitly asks itself what steps are most likely to fail entirely. It looks for places where the logical flow could easily break down.
It searches for simpler or much safer approaches to the core problem. It doesn't just blindly follow your initial prompt anymore.
It tests the proposed plan. Then it improves that plan before working.
If you're using Claude Code in a complex environment, this is vital.
It ensures the new plan won't accidentally break nearby connected files. It ensures it won't edit the wrong section of a delicate script.
Even a very clean-looking plan can rest on terribly weak assumptions. You might ask for a rewrite that ends up sounding much better.
But it could drift entirely away from your real creative brief.
The attack phase catches that stylistic drift before the generation happens.
Or you might get a code fix that solves the visible error perfectly, but it silently breaks something crucial in a related database file nearby.
That is the Fable 5 habit we are copying here today. Challenge the architectural plan before ever executing that plan.
Beat. So what actually happens if the plan is deemed too risky by the AI?
It halts the entire execution process immediately without making changes. It clearly explains the specific risk and asks you for further clarification.
It stops, flags the risk, and asks you for clarification.
It refuses to proceed until that identified risk is humanly mitigated.
Let's say the plan survived the rigorous attack phase successfully. The execution actually happened based on that newly improved blueprint.
But we are not completely finished with the workflow just yet.
Human nature is to blindly trust a really clean-looking output.
Step 4 is designed to stop that dangerous tendency completely. Verification means aggressively comparing the final generated result against multiple things.
We force the AI to check it against the original request you made. We check it against the gathered evidence from Step 2.
We check it against the improved plan we created in Step 3.
The ultimate goal is to catch anything that remains unsupported. We actively look for off-format text or logically weak arguments.
Here is a crucial point to remember for implementing this workflow. When the AI finds a mismatch, Opus should only fix the exact failing parts.
We should never do a full, sweeping rewrite of the entire output.
Absolutely not. That introduces way too much chaos.
It's like finding a typo in Chapter 3 and only reprinting that page instead of burning the whole book. If you rewrite the whole book, you might introduce 10 new typos.
That is the perfect way to visualize the danger of full rewrites, when the initial answer mostly matches your original scoped request.
You absolutely do not want a complete rewrite just to sound slightly better.
If a logical gap shows up, Opus fixes that exact localized part. It leaves the rest of the highly functional text entirely alone.
In Claude Code, this targeted verification applies directly to your local files.
Opus verifies the updated file immediately after making the specific edit. It doesn't rely solely on the chat interface memory to assume success.
It reads the newly saved file to ensure the patch actually worked. This verification loop stops Opus from ending the task prematurely.
A result can look wonderfully finished while entirely missing the real request. You might get a smooth, persuasive section that completely skips a word count constraint.
Or a code change that successfully fixes one specific isolated issue, while leaving a deeply related dependency file completely untouched.
We absolutely must verify the final output before saying we are done.
2-sec silence. Quick question on this verification step. Why exactly is a full rewrite a bad thing if the AI offers it?
Sweeping rewrites introduce brand new variables and completely unverified assumptions. Pinpoint fixes isolate the specific error without destroying the existing structure.
Full rewrites introduce new errors. Pinpoint fixes protect what already works.
Protect the established foundation at all costs during the verification phase.
The work is finally done and it has been fully verified. But for the user to truly trust this entire automated process,
The AI needs to hand the work over with complete transparency.
Step 5 completely eliminates the incredibly vague done message we usually get.
Reporting means Opus explicitly tells you what it actually did behind the scenes. It must clearly explain what specific tasks were fully completed.
It details what exactly changed after the verification pass caught an error. It also states clearly what is still considered uncertain or unresolved.
Confidence calibration is the absolute core of this final reporting step. Opus explains exactly how sure it is of the final result.
It bases the score on the task complexity, the evidence, and the verification.
If something remains mathematically or logically uncertain, it shouldn't hide it.
It shouldn't mask its own structural doubt behind a very confident, authoritative tone.
This reporting step makes the entire Fable workflow much easier to trust. You get the actual final output, plus the detailed status behind the output.
This provides immense psychological comfort to the daily user. It transforms the AI from a mysterious, unpredictable black box.
It becomes a highly transparent and surprisingly honest collaborator.
You aren't just crossing your fingers and hoping the code actually compiled.
You know exactly what Opus reviewed in the background while you waited. You know what it checked, what it fixed, and where to be careful.
Claude Code helps this final report reflect the true project state. The final report comes from reading the actual altered project files.
It doesn't just come from the short-term memory in the chat window.
Don't just finish the task, explain exactly how solid the work is. So what should a user do if Opus reports back with low confidence?
You read the final report, find the missing context, and supply it. Then you simply let the system run the 5-step loop again.
You step in, provide missing context, and run the loop again.
That is the true iterative loop of modern human-AI collaboration.
We are getting ready to wrap up our deep dive today. Let's summarize the overarching theme we explored throughout this entire framework.
The true lasting value of the Fable 5 model isn't magic.
It isn't a secret proprietary algorithm or a hidden beta feature. It is a strict structural discipline applied to artificial thought.
It is fundamentally about capturing a highly repeatable, scalable working style.
Let's recap the exact conversational flow briefly for you to remember. Understand the job before you make any assumptions about the output.
Check the materials you actually have in your hands right now.
Attack the blueprint aggressively to find the hidden logical flaws. Verify the final build against the original constraints of the request.
And finally, rigorously report the true integrity of the finished work.
Claude Chat is generally enough for a quick, simple text test, but Claude Code makes absolute sense for real, complex, local files.
You're finally giving Opus a rigid structure it can reuse repeatedly.
The final generated answer feels much more grounded, nuanced, and trustworthy. 2-sec silence. I want to leave you with a final thought today, something to mull over as you go about your work this week.
It is a really fascinating philosophical pivot from our technical discussion.
If forcing an AI to scope and find evidence works this well, if forcing it to actively attack its own assumptions produces vastly superior results,
Think about the broader implications for our own human collaboration.
how much better would our own human teams perform on complex projects? What if we rigidly applied this same five-step Fable workflow to ourselves?
What if we used it in our own daily stand-up meetings?
We constantly expect instant answers from ourselves and our busy colleagues, but maybe we really need to slow down to actually speed up. Maybe we need to attack our own plans much more often. Thank you for joining us on this deep dive. Outro music.